what is a coordinate vector? So we have three vectors here, v1, v2, and x. And let's say we let set B be the span of v1 and v2. Now v1 and v2 are not multiples of each other, so they're linearly independent. If they're linearly independent and they span a set, then we say that they are a basis. And B is a subspace because it's the span of a set of vectors. So we'll call beta the basis of B, and it's going to be just the vectors v1 and v2. So basis is like they're like building blocks for a subspace. So we have x, and we want to know what's the coordinate vector for x, meaning if we take one of those linear combinations of v1 and v2 to get x, we would say the coordinate vector for x relative to the basis will be the weights that you need to apply to the basis vectors to get that x. Right? So in other words, if we were to put v1 and v2 into a matrix, multiplied by c1 and c2, and set it equal to x, this vector here would be the coordinate vector. So it's just a system of equations. We just need to augment this matrix with x and solve it. So when you row reduce this, you get 1, 0, 0, 0, 1, 0, and 2, 3, 0. So it has a solution, and the solution is 2, 3. So that means the coordinate vector for x with respect to the basis beta is the vector 2, 3. And you can see if you plug in 2 for C1 and 3 for C2 and do the linear combination, you will get x. So 2 times 3 is 6. 3 times -1 is -3. 6 minus 3 is 3. 2 times 6 is 12. Plus 0 is 12. And here we get 2 times 2 is 4. Plus 3 is 7. So that does work. So this is what we'd call the coordinate vector.